The first thing we're going to look at today is linear patterns. We're going to use linear patterns so we don't have to write out each triangle in order to get the total. So these make it easier to just use an algebraic equation. So we're going to make a rule for how many matches and triangles make up if we wanted to get to a certain number. So right here we're just going to have the triangles. Now we're going to have the number of triangles. And then in the last column, we're going to have number of matches. So we're going to start out just with one triangle. So we know that's 1. And counting up these, so I have number of matches, or this could be sticks. So we're going to have 1, 2, 3. Okay, now we're going to keep going. So we make the regular triangle, and then we're going to make another triangle. So we have 1, 2, 3, 4, 5 lines now. And 2 triangles. And we're going to try this one more time and see if we can see a pattern start to form. So we have 1, 2, 3. So now we can add up. There's 3 triangles now. And there's 1, 2, 3, 4, 5, 6, 7 matches. So something that we can see is there's a common trend of +2 in between the number of matches per one triangle. Per 2 per one triangle. So now what we can do is we can see that that forms a pattern, and once we know the rule, we're able to jump numbers. So now we know that we can group these. The first group can be one group of 2 plus 1. The reason I did that is you see the 3 right here, and so we can do this and just do there's 2 groups of 1 plus 1. And for the next one, there'll be 2 groups of 2 plus 1. And then the third would be the same thing except for 3 groups of 2 plus 1. So this is kind of the same thing as having multiplication. So we have the 2 plus 1 here, so the second one would be 2 plus 2 plus 1. And the final would be 2 plus 2 plus 2 plus 1. Now the easier way to do this would be multiplication. And so we're able to go, this would be 2 times 1 plus 1. The next one would be 2 times 2 plus 2, and the final one would be 2 times 3 plus 1. Sorry, the second one should end in a plus 1. Now the number of matches is going to equal the number of triangles is 2 times 2 plus 1. So now that we have this pattern, we're able to jump into a number that we want to get to. So now that we've completed the diagram, I kind of rewrote the chart over here so you can see the number of triangles and the number of matches per set. And so now we have a few questions to answer. The first is how many sticks are in the next diagram? So if we were to do this again, how many would we have? So one way we could do this is just by drawing it out. So we have 1 triangle, 2 triangles, 3 triangles, and then a 4th triangle. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our answer is 9. So we're going to have 9 matches or 9 sticks in the next diagram. And so how many sticks are in the 10th diagram? So now that we know that before this was, the first one on here was 2 times 1 plus 1 equals 3, we can just add in a 10 instead of that 1 to get the correct answer. So this would be 2 times 10 plus 1 equals 21. So there will be 21 sticks in the 10th diagram. The final question we have is to write an algebraic sentence and to describe this system. And so going off of this, we know 2 is the number of lines aside from this original, and then this is the number of sticks right here. And then this will equal the total number of matches. So we're going to write 2s to represent the sticks plus 1 is going to equal the total number of matches. So 2s plus 1 equals the number that we need. So that will be our algebraic expression. So now we can use that for anything we might need. So let's say we wanted to do the 20th. We could go 2 times 20 plus 1 would equal 41. So now we know what the 20th would look like without going through each individual one. So this logic will be easy for students to understand, and it'll also save a lot of time in the process.